So in A, we want to determine the conditional density of theta given that x is equal to k, where k can be some non-negative integer, 0, 1, 2, and so on, so on. So let's try to find this by using the lemma 523. So the conditional density of y given that x is equal to k. Okay, so let's just say let k be some non-negative integer, right? Then this conditional density, well, using the formula, it's given by f theta of y multiplied by the probability that x is equal to k, where k is just the one data point that we have, given that theta is equal to y divided by the probability that x is equal to x. Again, we have only one observed claim number, x. So this turns into something that is rather simple. Let us recall the probability, what do we call it? Probability mass function, the point probability in the Poisson distribution, since we know that x given theta is Poisson distributed. Then we can see that what we have is f theta of y divided by the probability that x is equal to, and actually, sorry, this should be k, right? So that x is equal to k multiplied by the Poisson distribution with parameter y's point probability in k. So that is e to the minus y to the k divided by k factorial. And there we are done with this part of the exercise. Now, the next part of exercise A asks us to calculate the Bayes estimator. So calculate the Bayes estimator mk, which is given by the mean of theta given x equal to k. So if our observed claim number is k, what is our best guess for what we expect the x to be in expectation? Now let's try to calculate that. Since we know that theta, given that x is equal to k, has exactly this density function here, then what we want to do is to find the mean value of this theta. So theta lives from 0 to infinity, and we will plug in its density function. And since we are calculating its mean value, we will have to take the density function and multiply it by y, right? So we will get y to the k plus 1 divided by k factorial dy. And if we want to be a bit creative, we can take the probability that x is equal to k outside of the integral, but that's not that interesting. So let's just let this be for now. And these are the two results that we get in A. I'll just write these over into the margin and see you guys in the next video for B.